Welcome to the short video. My name is Marcus Willems. I'm Product Marketing Manager at Synopsys, in charge of our ASIP tool portfolio. ASIP stands for Application Specific Instruction Set Processor. It is a custom designed processor tuned to a specific application or application domain. So why would you design your own processor in the first place? Well, there are two main reasons. First, you cannot find a standard processor that matches your specific requirements. And second, you cannot go with fixed function hardware implementations as you need the flexibility as offered by a programmable solution. With an ASIP, you're indeed looking for the right balance between hardware efficiency and software flexibility. Designing your own processor used to be limited to a few experts, as it involves not only the hardware design, but also the definition of the instruction set itself and the development of a fully featured software development kit, or short SDK. This is where ASIP Designer comes in. It provides the most efficient way to design, implement, program and verify your application-specific processor. So let me briefly explain the tool flow. It all starts with describing the processor in NML, a registered transfer language tuned for the specification of processors. It allows to define the resources, the instruction set, and the behavior of your data paths and interfaces. From this processor description, ASIP Designer will automatically generate a fully featured software development kit, including a C++ compiler, as well as an instruction set simulator. And it comes with a graphical development environment that allows for efficient debug and profiling. And yes, ASIP Designer creates a C++ compiler even for the most specialized processor architecture, something we're going to cover in a separate video. Thanks to the immediate availability of the compiler, it is possible to use the real application code to profile the performance of the selected architecture and to identify the remaining bottlenecks, which then allows to go back to the NML model for an enhancement. We refer to this as the compiler-in-the-loop methodology, emphasizing the importance of an immediate availability of the compiler. Using the same NML model, you can generate fully synthesizable RTL code. All information is contained in the NML model, and you have full control on the way the RTL code is structured, which turns out, by the way, to be very readable. Using your standard synthesis flow, you can measure. You will get information on area, timing, and power consumption, which might identify the need for some changes to the processor architecture. This synthesis in the loop approach marks the second feedback loop, enabling a truly profiling-based architecture design. Finally, ASIP Designer provides comprehensive support for the verification of the processor, including formal checks, automatic creation of test programs, and system Verilog-based test bench generation. Of course, ASIP Designer comes with a wide range of example processors written in NML and provided in source code. These include microcontrollers, including various RISC-V ISA models for both 32-bit and 64-bit, but also vector processors in VLIW architectures, as well as highly specialized application-optimized cores. For all of these, you can generate the SDK and the RTL right away. They serve as a modeling reference as well as a starting point for your own design. We will cover these example models in some more detail in a separate video. Well, this was a very quick overview on ASIP Designer and how it enables to design your own custom processor within time, within budget. Not a surprise, ASIP Designer is being used by the majority of the top 10 semiconductor companies. And more than 300 products have been released based on ASIP Designer. If you'd like to get more information, we'd love to hear from you. We will be happy to provide you with more collateral or to arrange for a demo by our highly experienced staff of application engineers. Thanks a lot for watching.